6-1, college algebra, real simple day, talking about polynomials, do a little quadratic formula, call it a day. Polynomial is an expression containing a finite number of additions. Finite means you can count them, right? It's not infinite. It's a finite number of additions, subtractions, multiplications of constants and positive integer powers of variables. You've seen polynomials before. All these things are polynomials. You got sums and additions of different terms, and they got some variables and some exponents and all that crazy stuff in there. The degree is the largest exponent of all the terms in the polynomial, and the leading coefficient is the coefficient of the highest degree term. Again, really simple stuff once we get into it, but this chapter, this unit, I should say, will pick up strong in the next couple of days. So let's take this easy day and soak it in. What the heck are we doing? How do we solve this stuff? So when we do some of the more difficult stuff, it's like, oh yeah, I remember what I need to do. So first thing they ask you is what the leading coefficient is. They are asking you what the degree is, and they're asking you what the constant term is. I like to figure out the degree first. The degree is, out of all these terms, there are 4 terms, which one's got the biggest exponent on it? Wouldn't that be him, right? I circle him, right? Circle him. The degree would be whatever that exponent is. This has got degree 7. What's the leading coefficient then? It's the coefficient of this term, which is 14. Cool? The constant term means what's the term without the variable with it? Wouldn't that be him? He's the guy with no variable. So that's a 2. Rock and roll. All of those were in base C, like just one variable was in there, nothing but C's. So easy to see what the degrees are. In number 2, you got some base X's and some base Y's. It's been a while since you've done stuff like this, but to find the actual degree of each guy, you need to take the term and add their exponents together. So I like to write them down. By the way, most of this unit will be on paper, not on my math lab. So just FYI, today's assignment will be on my math lab, though. So what's the degree of him right here if you add the exponents together? 6. I like to put that underneath there. This guy's degree, don't forget about Mr. 1 right there, is a 5. This guy's degree is also a 5, which that can happen, no big deal if they have the same degree. And this guy's degree is a 7. Correct? All we got to do is find the biggest degree, which is, again, a 7. And what's the leading coefficient? Don't get optical illusion. It's not 3. It's negative 3 in front of there. What's the constant term? The term with no variables in it. Everybody does have a variable, so whose constant is 0. Right? It's just like you got a +0 at the end. Rocking and rolling. So let's do that here. Find the degree of him. The whoopsie daisies, people put 1. You got 1 plus 1 plus 1, which is really 3 for a degree. This guy's degree 4, 5, 6, 7. This is degree 9, and this has degree 0, right, because there are no variables in there at all. So that's got a 9th degree, leading coefficient of negative 16. And who's the constant term out of these bad boys? 110. Cool. Why don't you do number 4 for yourself there? All powers of x, so simple. Yes, sir, Bob.
Okay, on this next set of problems here, we're solving quadratic equations. And on these first 4, we're totally going to solve them all by complete the square. First of all, they kind of tell us to. And because the a value is 1 and the b value is even, that is the best time to complete square. And these aren't going to factor. Like, that's the whole point. I can't find 2 numbers that multiply together to be 10 and add together to be negative 6. So they're not factorable. And I think complete the square is the easiest way to do it. So the way you do that again is you set them up with a blank. You get all the stuff with x's on one side with a blank. And you got to add that dude over, or in this case subtract, and set him up with a blank. And to fill in the blank, you do half the b value squared. So half of this b value is negative 3. Squared is 9. So I'm going to add 9 to both sides. And then this is the part that students struggle with. This is now what's called a perfect square trinomial. It always factors to be the square root of the first guy, which will always be x because we're always doing it when the a value is 1, and then the square root of this guy, which is 3, and the sign from the middle. Or another way to say it is that's half your b value, and the quantity will be squared. Over here, we just add these up and we get negative 1. And now that we got a quantity squared all by itself, you can get rid of that quantity squared by square rooting both sides. So those cancel each other out, and you're left with x minus 3 equals, you're going to always have a plus or minus in this case, and since we've got a negative underneath the radical, we'll get an imaginary dude. The square root of negative 1 is I in that case. And to solve for x, it's pretty simple. You just add 3 over. So you get 3 plus or minus I. So there's two answers there. One of them is 3 plus I, and the other one is 3 minus I, plus or minus. Completing the square on this one again because the a value is 1 and the b value is even, and it won't factor. So x squared minus 4x plus blank equals negative 2 plus blank. You set it up with blanks, all the constants go over on the other side. So fill in half the b value is negative 2 squared, which is 4 in that case. So that goes to both sides. This home slice will factor to be x square root of this guy, square root of this guy, sign from the middle, quantity squared. Add those up, you get a big old juicy 2. Then you can square root both sides. And when you do that, this will become x minus 2. That'll equal plus or minus the square root of 2. And the square root of 2 doesn't simplify or anything, so we're just going to leave it like that. That is a real number. And x will be 2 plus or minus the square root of 2. So our two answers, 2 plus the square root of 2 and 2 minus the square root of 2. Completing the square. Over here, another reason we want to complete the square is because we can't factor it. A is 1. It has to be to complete the square. B is even. It doesn't have to be even. It's just so nice when B is even. You can complete the square when B is odd. It's just a pain in the rump, man. There's a better way to do it. So we will subtract the 41 over, and half the b value is 4. Squared is 16, and then x plus 4, quantity squared. That's the square root of this guy, and the square root of this guy, and the sign from the middle, quantity squared, equals negative 25. You add those up. Square root both sides, x plus 4 equals plus or minus. If you square root, remember, this is going to give you an imaginary number, but 25 is like a perfect square, so the square root of that would be 5, but you need an I with it because it's imaginary. And then you'll get x equals negative 4, because we'll subtract that homeboy over, plus or minus 5i. And there's our two answers, negative 4 plus 5i, and negative 4 minus 5i. So nice. Just one more of these bad boys. To set them up to complete the square, we want to get all the x's on the left with a blank and subtract that dude over with a blank. Half the b value is 1. Squared is still 1. Meow, meow. Quantity equals negative 12. Square root both sides, plus or minus the square root of negative 12, which can be simplified. You know, if you just think of it as the square root of 12, that's the square root of 4 times the square root of 3, which is 2 square roots of 3, but you need an I with it because this guy was negative, so you need to slip a little I in there. So x plus 1 equals plus or minus the 2i square roots of 3. That's what the square root of negative 12 actually simplifies to be. Then you subtract that over. So minus 1 plus or minus 2i square roots of 3, and we put this guy up in here. We got a plus. It doesn't matter which one comes first. One of them is a plus. One of them is a minus 2i square roots of 3. So we completed a square on these because a is 1 and b is even. On the next set, a is 1. A might be 1. A might not. A definitely may or may not be even. So the quadratic formula is probably our best. So we'll practice with that now. This guy,
Kind of close to standard form, but not quite. And let's see if we should complete the square on him or do the quadratic formula. So a is not 1, but I could get him to be 1 by dividing everybody by 3, but this won't divide out by 3 very nice, so I'm going to use the quadratic formula. No, complete the square. A equals B equals C equals. So 3, 12, negative 7, opposite of B, plus or minus the square root of B squared, 144, minus 4 times A times C, all over 2 times A, which is 6. That's really a big mistake, because people always put a 2 down there. It's 2 times A. Punch in that discriminant. 144 minus 4 times 3 times negative 7. I can't reach the negative. 288. So negative 12 plus or minus the square root of 288 all over 6. Square root of 288 will totally simplify. Doesn't 144 go into, oh, 228, my bad. Looking at my answer key and it didn't match up, but 228. Well, let's see if 228 can simplify. Let's work backwards on the list and see if we can find ourselves a perfect square. So I'll let you pause the video and see if you can find one. And hopefully you found that 4 goes into that evenly. So you're going to pull a 4 out and it gets square root as you become a 2. And that went in there 57 times. And then there's a 6. And check out your triangle of death. Each one of those has a factor of 2 in it. So negative 6 plus or minus 1 square root of 57 all over 3. And there's our answer, right? The triangle does not reduce anymore. People are like, well, don't those cancel or reduce? Not really, because you've got more than one term up here in the numerator. So negative 6 plus the square root of 57 all over 3. Negative 6 minus the square root of 57 all over 3. Fabulous. You try 11. See what you would do. Would you complete the square or would you do the quadratic formula? And then get it. Well, I'll do it together. Remember, there was something weird about this one also. So this one, A is not 1, and I can't divide everybody by negative 3, so it's quadratic formula. So negative 3, 18, and negative 11. Opposite of B, plus or minus square root of B squared. So if you don't know what 18 squared is, let's just punch him in. Remember, you got to punch him in. He's always going to try to be positive, so don't ever put a negative number in this one little spot right here. Minus 4 times A times C all over 2 times A, which is negative 6. And then you could punch in that discriminant for me real quick. And I hope that you get 192. And 192 can simplify. So see if you can find the biggest perfect square that goes into that evenly. And it was 64. So since 64 goes in there, you'll have to square root him and get an 8. And it went in there 3 times. And that's all over negative 6. And then we can simplify with the triangle of death. Looks like 2 goes into all of those bad boys, so negative 9 plus or minus 4 square roots of 3 all over negative 3. And then what you can do is, you see you got a negative over a negative here. You could leave it like this, or you could actually the negative over the negative, because people are like, well, it's not really negative over negative. It's like this guy's not negative. Well, part of him is, you know. So like in some cases you have a negative over a negative. In some cases you don't. But you can simplify it to be 9 plus or 4 square roots of 3 over 3 and 9 minus 4 square roots of 3 over 3. If you left both of these front guys negative, it's really the same answer in both cases. So it doesn't matter to me, but when the first two dudes are both the same sign, both negatives, you can simplify.